Dear ladies and gentlemen, it is my pleasure to welcome you to IDEA product webinar on IDEA StatiCa concrete and prestressing workflow, especially with SCIA Engineer and other analysis software. My name is Jaroslav Navratil. I'm Technical Director of IDEA StatiCa company, and we will give a seminar or webinar together with our product specialist Filip Adler. We prepared a short presentation, and we will show you also an example of the workflow with SCIA Engineer in live presentation. You can of course ask the questions by writing the questions into the chat of GoToMeeting, and Philip will take care of it so that he will deliver it to me and he will tell me. And I will answer the questions after my presentation. So, first of all, we start with various types of IDEA StatiCa workflow. As you can see, we have 4 types of workflow. First type, A, is actually the import of results into IDEA StatiCa Beam or IDEA StatiCa RCS. We can import the results via Excel table by simply copying it into the clipboard and to RCS program, or using SCIA XML document, output document. A second level or second type is import of structural model and also results into IDEA StatiCa BIM. You can see all the programs which we support in IDEA StatiCa prestressing and IDEA StatiCa concrete. Third type, C, is the import of direct import, I would say, into IDEA StatiCa BIM. In case that you have some program, for example, a robot structural analysis which doesn't have construction stages and prestressing, you can click on the beam and export it directly into IDEA StatiCa BIM and continue with this sophisticated features and design of the beam. Type D is actually rebranding of IDEA StatiCa so that we produced external module which is linked to 3D systems via COM interface. It is especially RFM, but also Axis VM. We are not saying that this A, B, C, D is the level of quality or that the A type is worse than the other one. The other way around, we believe that it depends on the type of the task which you have, and according to this type, A, B, C or D type of the workflow is suitable. But before, when we speak about specifically SCIA Engineer workflow and with IDEA StatiCa design, and we organized the webinar for Dutch and Belgian customers today, so we have to speak about SCIA Engineer. You have to do certain steps so that your export of the data from SCIA Engineer is successful. First of all, you have to close SCIA Engineer. You cannot do all the next steps with the program opened. Then you should go to this folder, Program Files, IDEA RS StatiCa 7 templates, currently StatiCa 7, which is the folder in which IDEA installation program installs the templates of SCIA Engineer, and we have to copy these templates into appropriate folder of SCIA Engineer by running templates installer exe. When you run this exe file, which is actually in this folder, then all the templates are copied into appropriate folder, and then you can start running SCIA Engineer. Then you should create, if you want to export the data, you should create new XML document using appropriate TDX template. It is done in this manager of the documents, and you simply add a new document, XML document, and select the appropriate template according to the type of the export which you want to make, and then you modify the output as required. I will show it in live presentation. And the first live presentation will be about this direct import of results into RCS, which is the type A of the workflow. We will have such production hall, and we will design this beam, which is beam B53 in SCIA Engineer. You can see SCIA Engineer file project, and here we have arbitrary beam with hinged cross-section B53. What we have to do is that we run the analysis. I have done it. So we need to have a results, and then we go to XML input-output document, and when you click on it, double-click, then the document is opened, and you can see I have already used the default. I can open the dialog which I showed in the presentation. I have already opened the template for IDEA StatiCa RCS, so I will not do it. The only what I have to do is to adapt the content, to modify the content of the document. You can see that, for example, at the beginning you have the cross sections, then members 1D, materials, haunches, and all other things, load cases. You'll see that I filtered all load cases, and for combinations I want to export internal forces on member. For selected combination, I selected one combination for ULS and one combination for SLS. For the list of the members, which I selected B53 only. I can select more of them, of course, but I want to have it only for B53 for this presentation. Then you press refresh of the document, and after it is refreshed, you can export it into the file, and I keep the default name of the file. It tells me that he wants to rewrite my old file. I say OK, and then we have exported all the data, and I can go to RCS program, and I create a new project. I select one of the section. It will remain empty anyway, and then I go to sections in the navigator, and you can see there is a possibility to import sections from XML file. Actually, this is the XML of SCIA Engineer. When I press on it, I select the one which I created today, which is this RCS with the name RCS. You see the date. I open it, and the program tells me that we have two combinations, with one for ULS and one for SLS. There are some named sections in SCIA Engineer, but I do not want to work with these named sections. If I wanted, I could. And he tells me that it created 6 sections. Of course, there is some material like hot-rolled steel, which we do not support in RCS, and only this cross-section was not recognized in the file. But that was the cross-section which we were not interested in. Actually, we imported from the template which I showed here in SCIA Engineer all the data, and the program IDEA StatiCa filters the data. So we created 6 sections. The first one is the original one, which I can delete. That was the one which I did not import. And this, you can see the T section, quite a deep cross section. Also this one at the section at 12 meters from the distance. This is the section at 0 above the theoretical support, which is actually in the haunch. This one is also in the haunch, again a little bit higher, bigger cross section. You can see it in info window, and this one is again at 9 meters. So I do not want to show it in this presentation, these haunched sections, so I will delete these sections. And I have only the one which I wanted to have, and my reinforced cross section is R2 CS2, which is taken from SCIA Engineer. When I go to reinforcement, I can show you that we have some internal forces, and by the way, I did not, probably I select this one to get proper design. I start with design of this, I would say, smart template, and in this moment the program designed the necessary reinforcement in real bars. You can see 13 reinforcement bars of diameter 16 at the bottom. Here we have this summary. When I say OK, then it tells me that this smart template doesn't consider so many layers of the reinforcement, so it didn't give me proper reinforcement. That's why, or sufficient reinforcement. That's why I want to use the template in which we do not check the detailing rules. And you can see that the program designed 9 bars of diameter 20. It is 18 meters span, so probably this must be very heavily reinforced, and you can see the program placed a lot of reinforcement in one layer. We do not check the collisions, even if we show it. And with this reinforcement designed, we can run all the sections. And you can see the detailing. Of course, I have to switch it off because we know that the distance of the bars is not correct. So we go back and we see that only this one interaction of all internal forces is unsatisfactory, and that was because we have in interaction very skew bending, I mean double bending, and the program tells us that shear is not satisfactory due to insufficient strength of shear reinforcement. Probably the lever arm was calculated very small. So we can go back to reinforcement, select the stirrups, and you see that stirrup was designed without relation to detailing rules, 95 centimeters at a distance 95, almost 95 centimeters. So let's put here 400 millimeters and 400 millimeters. And then we go to sections and we calculate it all, and it should all be okay. We can select, for example, the last one. We can go to results and go through capacity check, shear, torsion, interaction, stress limitation, crack width, and I didn't switch on the response, which is actually not necessary, but it gives us very nice information about the behavior of the program. So that was the presentation of this possibility of input of the results. Second one is actually still the type A, which is the workflow with import of results only, but into a beam of IDEA StatiCa. This is an example from our Dutch customer. It is post-tangent bridge slab, which is modeled by 2D elements in SCIA Engineer. It was a little bit skew, and designer wanted to have the tendons at the distance 56 centimeters. That's why we defined integration strips in order to integrate on the internal forces, and the width of the strip, as you can see here, was 56 centimeters. Then what we did in SCIA Engineer was the analysis of moving loads only. You can see the load cases caused by the moving loads, and nothing more was analyzed in SCIA Engineer. Then we exported the data similarly as I showed you in the other example, but with different template. This was the template for beam, not for RCS. The program SCIA Engineer created XML files, and there were just the moving loads effects stored in that file. Then we imported it into IDEA StatiCa beam by simply clicking one button. You can see the dialog, and we imported the integrated forces from that strip. Then it is possible to define the load groups, or to specify the load groups, bridge load groups, for each imported load case, and to do all the design of the prestressing. You can see plane XY in the plan, this elevation XZ plane. By the way, it is possible to use vertical scaling of also horizontal, but in this case it is important vertical scaling. And also we can draw draft drawings of the tendons with all the straight and curved parts identified, and also with the spacers. You can see the dotted lines as the spacers and distances of the spacers in the stationing. You can export it into the XF files. And of course we can define construction stages, predefined construction stages in IDEA StatiCa beam. So the data is generated automatically with no specific knowledge required from the user. Of course, the losses are calculated, equivalent loads caused by prestressing. We run time-dependent analysis, TDA, with the effect of creep and shrinkage, including nonlinear creep, and we give you all the internal forces, and we also can calculate or run complete IDEA StatiCa checks of the sections, which you already saw, and you will see it more in the live presentation of the composite bridge, which will show you Philip. Philip, can you please? I will give you a presenter.
Yes, definitely.
Thank you.
So just let me clarify that you see my screen.
Yes, we do.
Yes, perfect. So let me begin. Let me start with showing you this this model. It was a composite 3-span bridge with I section. Maybe I will show you the section. Pardon, it's this one. So we modeled this shape from the XF file, which has been imported, and we added a composite slab. Then we modeled the whole geometry and supports and so on. Actually, this bridge is reinforced by prestressed strands, which I will show you in a minute. This is how the tendons layout looks like. So I switched on just the plane XZ. It's a combination of straight and draped tendons, which are defined here. And also we calculated the equivalent loads. So this is some basic view over the model. We defined several load cases, so most of them are generated automatically by the program, and we edit just the uniform distributed loads for calculation. The only thing which we needed to add, what we are not able to provide you with, is or are internal forces from moving loads. So to do that, we used a 3D model in SCIA Engineer. So it was a slab with ribs with this cross section which I mentioned, and to have the results, we have taken the results from the rib or integration strip. As has been mentioned, we can go to the tools and XML document, and I will show you actually how it's done. So I will select the new document and load a template. From the installed templates, I used the template called user defined forces, and it's loaded, so I need to select the desired members. So I checked which one I need, so I actually needed it to be the B6, B35 and B64, and then we can go to the load cases and we can select all the moving loads, and for example I don't need the self-weight, so I just give it back. So I choose the right members and I choose desired load cases for moving loads, and in this case I'm working just with load module 1. I could define several more load cases like LM2 and 3 and so on, but to save some time I will show you just the basics. So now we should refresh this document as it is set, and then it's done by this button, and after the refresh we click on the button export, which will automatically create the XML and XML.def files which are needed for successful import into IDEA StatiCa. So how do we add the moving load cases and correspondent internal forces? I can go to user defined forces tab and click on the button import from XML. As you can see, I will just select this XML file which I already generated before, and I will click that I will import all internal forces, and they will begin in the beginning. After clicking OK, it will take just a few seconds to import all the values, and it has been said that 28 load cases has been imported. You can go through all the results if you wish, but let me show you briefly the workflow with this import. So what I need to do is now to actually go into the load cases again and to set all the models to the correspondent load group. I have actually done this previously to save some time, and when I have all this done, I can go to the combinations and just add manually these moving load internal forces to the combinations in the last stage. So I will just click on the whole group and click add. Also for serviceability limit state combinations. Okay, last one. And after clicking OK, I have everything set to run the TDA calculation. which means that we are taking into account all the construction stages, all the creep, shrinkage, and so on. It will take a few seconds of computing time, and after it is done, I will show you the last steps to get to the checks and results.
Maybe I can explain this nonlinear creep effect. Actually, this is not an academic feature. This is something which allows you and which improves the economy of the design, because then you can skip certain checks for 45% of FCK when you check the stress limitation of the concrete. So this is possible to switch in the settings of construction stages. By the way, Philip, maybe you can show just in several seconds all the construction stages when you go through one after the other. When now don't change anything so that we do not need to calculate it again, but we can show it. I suppose you didn't show it. You haven't shown it.
Yes, I haven't. Okay, so there are several construction stages defined. So the first is defined, it's simply supported beams separately, which are now just in a formwork. Then we have a stage of prestressing, so there are supports in the ends of the beams. Then we use some storage yard stage with defined supports in projected position. Also the stage for transportation, we can use another position of temporary supports. We can, for example, add several more supports if you wish, or use, for example, the camber. Then we cast the continuous composite slab to make it a continuous span bridge. Modify the supports to be in final position. We can have a stage to add superimposed dead load, and then we have a stage of end of design working life, which means that we put all the traffic and so on and live load there.
Thank you. And you also can see in the column called check that we require the check of all sections in all of these construction and service stages, which of course you can switch off, but now the program will generate quite a lot of data to check. Okay, you can continue. Thank you.
Yes, maybe one more thing, that we are able to provide you with user input of compressive strength of concrete in time. Maybe do you want to add something for this functionality?
I think that would be beyond the scope of the presentation. Let's concentrate on the workflow.
Yes. Okay. So let me show you the internal forces now for all the ULS combinations. It will take some time to. Yes. So this is the shape of bending moments for all ULS fundamental combinations with all the critical descriptions. I already have defined some reinforcement in this example, so I will not give any time for this, but we can go directly for the results, which will also take some time.
All the checks are done in nonlinear calculations. Even the calculations for SLS checks are nonlinear because of the cracking. According to Eurocode, we have to respect when the crack appears, and then we disregard the concrete intention. So that's why we do it.
Okay.
Now we will see the results in selected sections. Maybe you can describe it later.
Yes, definitely. So there we can see just some overall check for all the checks, or we can go through all the construction stages and see which type of check was the limit. Or if you wish to have the more detailed results, you can go by the detailed tab into the RCS. It will take just a few seconds. Okay. And in RCS, we can check everything detailedly. So let me go, for example, just for one section to speed this process. It will calculate now briefly. Yes. Okay, and you can go through all the construction, all the stages and all the results. So, for example, I can go for stress limitation, and when I go through the construction stages, I can see how the stresses are changing. Maybe I should turn on the response.
Yes, it's better because some of the combinations for serviceability limit states are not in that extremes generated by BEAM program.
Yes.
Because we have more ULS combinations than SLS combinations. Okay.
Yes, and you can see through all the through the time how the stresses are changing. Yes, and so we will reach, for example, the stage where we are casting the composite slab. There it is acting like a load, and in the next stage called final supports, it's already stiff enough to bear some stresses. So you can see in a diagram that we have some deformations and stresses also in a slab. Okay. One more thing, maybe it has been already mentioned that, for example, for a torsion we have this let's say equivalent thin walled section, and we had it calculated automatically. So maybe just to show you, if you will face this sometimes, you can go into the stirrups, and when I click on stirrup, you can see I have just one stirrup checked for the torsion. Sometimes the program automatically recognizes, for example, this stirrup as a closed one, so it would be checked for torsion. And as I will show you, when I go to the user settings and torsion, that program calculated the wrong equivalent section, which means you have to go for
Actually not wrong, but calculated it from the area and perimeter of the cross sections, because there was not possible to calculate it from two stirrups. So the program was confused. So sometimes it's better to concentrate on one stirrup, or of course you do not need to define the stirrups, I would say, in CAD way, CAD way, because we are not drawing program. And if you really want to have also these flanges effective for torsion, then you would have to define one stirrup around all the vertices of the cross section. Then we, or not we, but the program will identify the equivalent in-wall section correctly. Okay, thank you. I think that's it.
Yes, that's it. We know all the results, and it is passing all the checks.
Perfect, thank you very much. Perfect presentation. I will show my screen now and I will continue.
Yes, maybe I will interrupt you for a little. There are currently no questions. Please feel free to type any. We will come for them in the end of the presentation.
Yes, thank you. And I can present it. Okay, so this is the type of the workflow B, which we can import a whole model, including the cross-sections and geometry of the model, and of course the results into IDEA StatiCa BIM. I originally wanted to show you the same example, but I realized that you can save some time, and I only show it in PowerPoint presentation. This type of the workflow is useful, especially if you want to use our design groups. For example, all these beams can be selected as members of one design group, and then we calculate the envelope of the effects, and we design only a representative member. It is good for the design of columns, especially in big groups. So this is the other possibility, and then you can definitely design this representative member, as I explained. You can perform the design in either directly in BIM application, or you can even export it into IDEA StatiCa BIM for prestressing. If you realize that this span, for example, of the beam is too long, it is 18 meters, and you could remember that we needed 9 bars of the diameter 20 millimeters to transmit all the loads, then it is clear that it could be better if we prestress such beam. Then it is possible, after the import into the BIM, we can export it into a BIM program and do the same analysis as Philip showed you. So that would be this direct import into BIM application would be type C of the workflow. And now we are approaching the end of the presentation with this possibility to use external modules which are linked to some 3D systems I mentioned at the beginning. This is the type of the workflow D. You can see the structure of building structure in RFM program, and actually the cantilever of in this part was 4.5 meters, and the distance or the span of the slab was more than 10 meters. So we needed to pre-stress these shallow beams and also these strips of the slab to improve the performance of the structure. So it is possible to use so-called RF tendons, which is actually IDEA StatiCa rebranded, to design the design strips and to design the tendons in these design strips. Actually, we use this example from the practice. I was involved in such a design of this residential house, which was very big, nice house in our country. The distance in the longer direction is about 50 meters, so it is significant nice structure. And this is what we designed, the tendons here, and this is a finalized structure. You might have a question why we should export the data into IDEA StatiCa. We already tried to mention the advantages. For example, in case of prestressing, we can show equivalent load, as you can see here. We can scale of the structure in vertical direction, we can produce draft tendon drawings and send it to the DXF file. In case of construction stages, we have time-dependent analysis, including the composite section and redistribution of the stresses. We can respect nonlinear creep in the analysis, which I have explained that it is a nice economic advantage. All our design is visual. All the intermediate results and even the assumptions of all the results are visualized, so you can see on the screen what is happening in each section for each combination. And of course we use innovative methods such as our interaction of all internal forces. And our IDEA StatiCa code checks are complete. You can see all the ultimate limit state checks, including fatigue, shearing, composite joint, and serviceability limit states, including decompression condition, brittle failure, and other checks. I would like to thank you for your attention, and that's what we wanted to show you today. I hope we showed and we proved that the workflow with IDEA StatiCa is effective and definitely also economic. So if we have any question, Philip?
No, so far.
Not so far. So let's wait for a while. And if we do not have any question, doesn't matter. We will put our recording into on internet, and you can see it again. You can think about your questions. You can send it to our reseller Emil Peltenburg, and we can definitely answer by email, so we can organize some special session. So if there are no questions, then we would like to thank you for your attention, and we wish you big success with IDEA StatiCa in your practice. Thank you very much. Bye-bye.
Have a nice day. Bye.